Welcome to the notes on intervals of increasing and decreasing in section 1.3. So let's talk about a few different types of functions. Let's suppose the first function is an upward sloping curve. Okay. This function is said to increase at an increasing rate. The reason the function is increasing is you can see as we travel along the x-axis from left to right, the function is positive, and the reason it's increasing at an increasing rate is because the slope is becoming more and more steep. Okay, so increasing at an increasing rate. Now, let's compare that to something that increases at a constant rate. Okay, so if I have something like this, this function would increase at a constant rate. This is just a linear function where the slope is constant everywhere. And there's one more scenario that you could probably think of if a function is going to increase. I encourage you to pause the video and guess what that is. Okay, so you may have guessed it. We're going to increase at a decreasing rate. Okay, so increasing at a decreasing rate. And the reason we're increasing at a decreasing rate is we're increasing, so the slope is positive, but the slope is becoming less and less steep, right? If I draw tangent lines to approximate the slope. Okay, so there are three ways that a function can increase. We can increase at an increasing rate, we can increase at a constant rate, and we can increase at a decreasing rate. All of the graphs are increasing because as we walk along the x-axis from left to right, the y values are going up. So the formal fancy way to say that is the y values are going up, right? Is to say that f of x sub 1 is less than f of x sub 2 as x increases, and these are just y values. All three derivatives are positive. Okay, so the derivative of all of these functions are positive, okay, because they essentially have positive slopes. Okay, in the next video, I'm going to talk about the ways in which functions can decrease.